All right, good morning, good afternoon, everybody. How are we doing today? Let me go ahead and get my video started up here. It's excellent to see all of you. Yeah, I know. So I did put the countdown timer up on the course page. So I have the actual number of school days written there. The countdown timer does include weekends though, so keep that in mind that it will show you weekends. But hopefully you kind of have fun with that. I did, Terry. I just need to go ahead and update your grade. Yes, Laura, that's exactly what we're trying to figure out right now. So you need to unblock Adobe. Instructions are on the board. All right, so everybody, I need you to go ahead and start giving me green checks once you're able to open up your virtual lab. It will most likely be blocked. So I do have instructions up here on how to unblock it. So we're going to try to unblock it now. I'm going to give you another chance to unblock it later. And if that still doesn't work, you can stay after class and we can work on unblocking it for you. I have always been able to unblock Adobe Flash. There's never been a problem I haven't been able to fix. So there are no excuses. You do need to get it unblocked and you do need to give me green checks once you've done that, okay? But again, if you can't get it right now, don't worry. We'll have another chance later. And then after class, we can also do it then. But you absolutely do have to get it unblocked at some point before you start your lab. Okay, so here are the instructions. When you first try to open up the link, and I recommend trying to open it up on Google Chrome. Some versions of Firefox don't even allow you to use Flash at all. So I recommend using Google Chrome instead. So when you first try to open up that link, it will most likely say that it's blocked. And so what you'll probably see is in the upper right, you'll see a little puzzle piece that has a red X on it. And that's in the URL bar. So it's in the actual place where you type a website. So that'll be in the upper right corner. You're going to go ahead and click on that puzzle piece and then click manage. Yeah, if yours is unlocked, awesome. That's exactly what we want. I'm only putting these instructions up because I know about half of you, it will probably be blocked. Okay, so you will click on that button. Click on that puzzle piece, and then you'll see it pops up. It'll either say manage or done. So click manage. From there, once you click manage, it's going to open up a new page for you. And on that new page, you're going to scroll down and find where it says this little sentence, block sites from running Flash. And there's a little button next to it, and you need to click on that button so that it turns blue. So what you want is you want it to say ask first and for the button to be blue. Once that's done, you are set. All right, so that means Adobe Flash will now work. So once you do that, you don't need to update Adobe Flash. All right, Anissa, if you want, stay after class. I'll tell you exactly what to do. There's a little bit of white text that says click here to run Adobe Flash. That's what you actually want to click. It doesn't look like a button for you, Anissa, but it is actually a button. So don't click update. Instead, look right underneath where there's a little bit of white text that says to run Adobe Flash. And again, even though it doesn't look like a button, it is, in fact, a button. They're trying to trick you, okay? And then once you have done that, all you need to do is you will go back to your original page where the virtual lab was. Perfect, Anissa, exactly. You'll go back to your original, again, there are multiple different problems. This is the most common one. But again, if you run into a problem like Anissa, stay after class. I will absolutely help you. We can always fix it. So once you've done this, go back to your original website and then just click where it says click to enable Adobe Flash Player. Okay, so one last time, I'm going to go ahead and show you what this looks like, and I'm going to actually show you step by step. Okay, why aren't you blocking now? Hold on. Okay, let me go ahead and go to an incognito window and try this one. Perfect. Okay, so let me go ahead and show you exactly what this looks like up on the whiteboard. All right, so let me share this with you up on the board. Awesome, your lab is loaded. I love it. Okay, I'm going to go ahead and move this over. Perfect. Okay, so what you'll see is when you first open up the website link, again, if you're in Google Chrome, which I recommend using because Google Chrome tends to work a little bit better, there's a way to unblock it. You will see this puzzle piece pop up on the top. And let me blow this up for you so you can really see it. You'll see a puzzle piece up here and it'll have a red X. Click on that puzzle piece, then click Manage. Okay, and from there, a new website will pop up. Okay. Sorry, it's got really big. 1 second. So you will see a new website pop up, okay? And right where it says block sites from running Flash recommended, you're going to go ahead and click that button and it'll turn blue. And now it says ask first. And that's what you want. So it says ask first. How are we feeling so far? Go ahead in the chat box. Give me a smiley face if that makes sense. Again, you click the puzzle piece, you click Manage, and then on your other window, click the button so it says Ask First. Perfect. From there, now we can go back to our original website, refresh it, and right where it says click to enable Adobe Flash, I'll click on that. You can click Allow. Sorry, I guess I forgot that step. Click Allow. And now you should be able to see your website, okay? So again, we absolutely have to be able to open this up. If for some reason you have a problem, stay after class, and I will give you a second chance later to try to get it open again. I do see lots of green checks though. I'm waiting on Angelina, April, Brittany. Again, give me your green checks if you're able to open it. Waiting on Cody, CJ, Daniel. Waiting on Dominic, Isaiah, Laura, Marissa, Zashiki, and Zion. Awesome. I am so happy that's working for all of you. Yeah, you don't have to have it open right now. I just want to make sure that you are able to open it. So if your computer's running slow, you can close it if you want. But if you're like Chilo and you want to play around with it, as long as that's not distracting you, I am fine with that. Perfect. All right, let's go ahead and move on to our announcements.
Good afternoon, everybody. How are we doing today? I hope we're all doing well. Just to kind of briefly go through our announcements because we have a lot to do in our lab today. Just make sure that you know to watch that announcement video for any announcements on class or in our school. And just can you believe it? 19 more days until Q4 ends. That's amazing. 19 school days. So today is May 20th. We're going to be doing our Solubility Lab. We're going to have class until about 2:45, and then any questions after that, we're here for you. You can always ask us if you want to open up your virtual lab then, or if you have questions about that, we're here for you. So right now we're going to be working on our 6C lab report and obviously getting that extra credit attendance. Hopefully we all got that. All right. So, and like always, and I'm going to push it right now, is our class sessions are recorded and distributed for learning purposes. Please don't put any personal information or information of others into the chat box for your protection and the protection of others. All right. I always lose my breath at that point. So here is a couple of announcements. Remember, to pass this course, you must get good grades on those essential assignments. Woo! Look at our pie chart. Look how big it's grown. Can you believe it? So we have all these essential assignments right here, including our 6C lab, and so now they're worth 10.8% of our class. With the 10% of Star 360, so right here, just in the red Pac-Man is 75% of our grade. You need to make sure that you are getting a good grade on these essential assignments in order to pass SCI102B, okay? Overall, 75%. But you will not pass even if you get 100% on all the notes. Remember, notes are only 25%. They're great and they're very helpful. They're great for the test, but that's not going to get you to pass. Even if you did the Star 360, that's only 35%. Again, easy math here, it's not going to get you to pass the class. So make sure that you get these essential assignments in and done well to really kind of lock in your grade of passing this class. If you are missing any essential assignments, since notes are only worth 25%, make sure you get them in. We're here for you to help us. Email us, text us, call us. This is what we're doing. This is what we live for as teachers. Please reach out to us so we can help you out with this. We want to see you passing. We only have 19 more school days. We don't want to see you at the end of the quarter panicking and trying to get everything in. It's stressful and not worth it. I will tell you, it's not worth it. So get it in. All right, with that being said, hopefully we got the idea. If, again, help, we're here for you. Unit 6, we've been talking about mixtures and solutions. We've been talking about the types of solutions and what's important of those types of solutions. And we're going to finally demonstrate all this working knowledge with our Solubility Lab today. So that's what we're all wrapping up in Unit 6. So today we're going to design an experiment based on the hypothesis and graph and analysis of some data that we are going to gain with our Solubility Lab. We're going to demonstrate how changes in temperature affect the solubility of solute in water, okay? And we're going to demonstrate this all by looking at our 6C lab. And hopefully with today and the help that we're going to be giving you, you'll be getting an 80% or higher. If you're doing that, good to go, okay? Here is our agenda in case you have any questions on what we are going to be working on today. Here it is for you. And if you have any questions, again, ask us at the end of class, okay? All right. So right now, what I would like you to do is I would like you to go ahead and open up your 6C lab report. Not the virtual lab, but the 6C lab report, okay? I'm going to stick that into that chat box. There you go. You got it from me, and then you got it from Mrs. Larkin. There should be no questions, and obviously if you can't find it here, then you go to your grades tab for that 6C lab report. And with that being said, I want to see some green checks. Holla out there, give me some green checks, people. And we have 34 of us in class. I should see some 34 green checks. Come on, green checks. We want to see some green checks. I feel like the Price is Right. I think my calling should have been the person on the Price is Right. All right, let's get those green checks. Come on down. You're the next person with the green check. Who is that next person? I need to see a green check from Alicia, Alvin. Let's get those green checks in. Angelo. That's no problem, Alicia. We understand computers can be temperamental and they may not load very fast. Awesome. All right. Brittany, give me a green check out there. CJ, give me a green check. Daniel, Diego, Dominic, give me those green checks. Isaiah, green check. Jade, green check. All righty, folks. We don't want to leave anybody behind, especially today. Okay, this is very important, this lab, and you want to get all the information. Again, yeah, exactly. If you're taking pictures or if you're using paper and pen, awesome. If you're taking screenshots, if you're ready to go, give me those green checks. Okay. All righty. Ooh, look at that. Mrs. Larkin is telling you we're giving some answers away today. Nice. We are. We're a bunch of kids. Hey, why not? All right. Let us continue on, folks. All righty, Mrs. Larkin. There you go.
All right, everyone, looking good. Let's go ahead and start talking about what we're going to be looking at today. So we are going to continue on with our topic of solubility, which means we're going to review this one more time. We've already reviewed it several times. Let's make sure that we really, really understand it. So remember that a solute plus a solvent gets mixed together in order to make a solution. Remember, solute is the short word and therefore what we have less of. It is what gets dissolved, like sugar or salt or tang or lemonade powder, right? Solvent is a longer word and it is the one that we have more of, and that is what does the dissolving. When you mix them together, you actually get a solution. Hopefully you see my blue plus red equals purple. So you get a solution, and a solution is a homogeneous mixture, which is transparent, meaning you can see through it, and it is uniform, meaning the top and the bottom look the what. Homo means what? The prefix homo means what? This is not notes. We are in a lab today, So you need to make sure that you have your lab open and ready to go. We will be answering several of the questions together. In the chat box, yes, homo means same, and so it looks the same throughout. That is what the word uniform means. It looks the same throughout. Top, if you took a sample from the top of the solution, from the bottom, from the left, from the right, from the center, it all looks the same, okay? Don't be scared of labs. We go through every step with you. And we always have Fridays where we're happy to take our time to go through and actually make sure you get 100%. So definitely come to support. Support is a great way to get 100% on all of your big assignments. All right, so saturation point, remember that is the point where you can no longer dissolve any more solutes and any additional solute will just settle to the bottom. So remember, saturation point is kind of like the conceptual point at which it stops dissolving. Solubility is an actual mathematical measurement. So solubility is an actual measurement of the max amount of solute that we can dissolve in a solvent. So the max amount that we can dissolve before it reaches its saturation point. Please give me a birthday cake if you understand the difference between saturation point and solubility. That's the spirit, Johan. All right, so just a review from yesterday and to continue practicing reading graphs, what is the solubility of potassium dichromate, which is made up of 2 potassiums, 2 chromates. So the letter C stands for carbon, but the letter Cr stands for chromium, and O, which is oxygen, 7 of those, in 40 degrees Celsius water, which is about 104 degrees water in what we would say in the U.S. So it's warm water. It's slightly warmer than your body temperature. Okay. But let's go ahead and take a look at potassium dichromate. What color line should I be taking a look at? I've got a rainbow of lines here. Which one is potassium dichromate? Let's first identify that. You're going to name your kid Chromium with a K. I mean, that sounds cool. I love the science influence early on. Yeah, so we can see potassium dichromate, you are correct, is the purple line. We're going to go ahead and we need to identify where 40 degrees Celsius is. Should I be taking a look at the left axis or the bottom axis? Where am I taking a look at? Where is 40 degrees? Is that on the left side or the bottom? Yes, it's right here on the bottom, which is actually called the x-axis, Jay. So this is the x-axis, the horizontal. The y-axis is the vertical. I should definitely actually include that vocabulary. I am not being a great math supporter right here. So yes, this is the x-axis, the horizontal. So here we go. This is going to be our 40 degrees. All right, on our x-axis, we're going to go ahead and shoot straight up until we hit the purple line right here. So I'm going to hit straight up. And then once you do that, look straight to your y-axis and tell me what approximately would be the solubility of potassium dichromate in 40 degrees of water. Go ahead, tell me in the chat box. Love it, seeing lots of answers. Yeah, 22 to 23. I think what I chose in the lab report for question number 1, I think I chose 23. And units, again, should be grams per 100 milliliters of H2O, of water. Because remember, we have to explain how much water we are putting it in. So we're putting it into 100 milliliters of water. This is the answer to number 1 in your lab report. Please go ahead and give me a green check when you have it saved. You have 20 seconds. It's multiple choice. Work fast, ready, set, go. All right, waiting on green checks from Zion, waiting on Rosie. Thank you, Natalie. Thank you, Rosie. Waiting on Jade. Green checks, please, Jade. Awesome. Thank you, Isaiah. Waiting on Hunter. Thank you, Hunter. Waiting on Diego and Dominic. Dominic, Daniel. Thank you, Daniel. Thank you, Dominic. Waiting on CJ, Kiko, and Brittany. CJ, Kiko, Brittany. Green checks, everyone. All right, let's go ahead and keep on moving.
All right, let's go back to our wonderful matching here. We have the term solute, solvent, solution, saturation point, and solubility. I want you to define these. I'm going to give you about 20 seconds. Remember, use a thin line, please. Do not, that is not red, okay, not red. So here you go. Awesome job. We got the first 2. Let's get down to the third few. There we go, everybody. Excellent. We're kind of a little bit across the board here. There's some that we're doing okay. We still have a little confusion here with saturation point and solubility, but we'll go ahead and take a look at that. I'm going to turn off your whiteboard tools. Thank you so much. Let's go ahead and review that really fast with us. Here we go. So we have solute, and remember that whole trick that we talked about where the smaller word is going to be, you know, those 6-letter words going to be smaller, so obviously the solute is going to be the one that you get the less of, okay? That's what gets dissolved in. That's the substance that you have less of. So here you go is solute. Solvent, okay, again, it's a bigger word, so obviously then we're going to go ahead and look at it, and that's what does the dissolving. More of the substance. So for example, water. If we were to put sugar into water, water would be my solvent. My sugar would be my solute. Solution is what is the homogeneous mixture that is transparent and uniform. That's what the whole thing is called when we have that homogeneous mixture there. Now here's where we got a little confused with saturation point. Saturation point is the stage at which the extra solute kind of cannot dissolve, so it settles at the bottom. Remember what we did yesterday with that, with the flour or and that when it's the cold water, and so the extra solute was kind of at the bottom. This is the conceptual, okay? Thank you, Mrs. Argan. Sugar and cold water, that's what I was thinking of. Remember, this saturation point is conceptual, so you can see it. You can, you know that if you have too much or if you have those floaters on the bottom there, then obviously we've hit our saturation point, okay? Solubility is a measurement. So when we hear the word measurement of the maximum amount of solute that can dissolve into a water, that is mathematical. Okay, the solubility is kind of the mathematical, what is mathematically going to be the most that solvent can hold of the solute. Okay, so please just kind of make sure that you are aware of that between the saturation point and the solubility. One is conceptual, where we can see it, we can experience it. We know that when we see the floaters at the bottom, it's hit its point. Solubility is that mathematical, and that's what we just did. All right, so this is number 2 in your lab. Go ahead and give me a green check. Green checks, go, and I'm going to stop right there. 45 seconds up on the clock. 30 seconds up on the clock. Remember to read carefully in your lab. These could be scrambled, so just read very carefully. Let's go. We have 37 of us in class. I have 29 green checks. I want to see a 100% effort here. We have 3 seconds up on the clock. All righty. I need to see a green check from Chilo. Or not Chilo, I'm sorry. You're good to go. Kiko. Green check. CJ, green check. Diego, green check. Sorry, Chilo. Nope, you are good to go. Hunter, green check. Hunter. Isaiah, green check. Let's not miss the bus here. And Zion, green check. All right, here we go. So let's do this mind map on the Solubility Lab. Here we go. We're going to jump into here what the lab is. Obviously, when we start an experiment or any lab, we have to go through what we call the scientific method, okay? We always observe first. I know this mind map's a little bit different, but we always make observations. What are we seeing here? How, think of sugar in cold and in hot water. What are we seeing here? And so we've talked about that. Then we go back and we kind of answer or ask ourselves a question. We have our question here for us, and it's how does temperature affect solubility? We question about it. Then we make an educated guess, and that's what a hypothesis is. We obviously go ahead and do our experiment, and then we analyze our experiment, and then we get our results, whether they are supported or not supported. If they're not supported, then we go back to the hypothesis and give another educated guess. And then we go back and through that process of experiment and analyzing, and then we get either supported or non-supported, okay? So the scientific method is extremely important when we are talking about any investigation around the world or any investigation that we're doing, and especially today in our solubility lab. We have our question, and we want to make those observations, get our hypothesis. Oh, did I go chipmunk on you? It's okay. And then we obviously perform those experiments, gather our data, and then draw conclusions about what we need to do. Do we need to redo the experiment again, or is it supported enough where we can make that we can make our theory about this? All right, so let's go ahead and do step 1. Obviously, we're going to use our senses. When we observe, we're going to use majority of our senses. Right? We have 5 senses. So today we're actually going to be using our hearing, our eyes, and not necessarily our touch or our taste or our nose, but we're going to use 2 of our 5 senses. So here we go. We're going to watch our video. I'm going to, Mrs. Larkin's going to go ahead and put that video up, and then she's going to.
Friends, on a hot summer day, we all feel like drinking something cold. And if the drink is sweet, it is so much the better. Today we will examine whether sugar dissolves more in cold water or in hot water. For this, you take 2 glasses. Fill one with cold water and the second with hot water. The right glass has hot water and the left glass and the middle glass is cold water. Take a sugar cube and put a sugar cube each in both the glasses. Then wait and see in which glass the cube dissolves first. You will see that there is much more activity in the hot water as compared to cold water. The sugar cube will dissolve much more quickly in hot water. If you don't have sugar cubes, you can repeat this experiment with ordinary sugar.
Now remember, we kind of already did this this experiment live with Mrs. Larkin with the sugar and with the hot and cold water. So you should already have an idea and already kind of know what to expect here. Remember, give me a green check. All right, so let's go ahead and I'm going to give you your whiteboard tools. I want you to use your typing tool. Remember, your typing tool is this one, the one with the A or the A with the lines, and I want you to use this section here. What did you observe? What happened? What happened in the video? Good. I'm going to go ahead and shut off our whiteboard tools. But what we did see is that in the cold water, obviously this sugar cube did not dissolve fast enough, right? And then obviously in the hot water, that sugar cube dissolved within seconds because of that hot water. And we talked about why that is. And so we're going to now make our question of whether we needed, how does the temperature affect solubility? That's where we get our question after we do our observation. So here is our question for today. We need to note that obviously, yes, I understand that this mind map here does take it into a different kind of order, but it doesn't matter as long as that you're using the scientific method, and the scientific method can be changed in whatever situation, okay? But what is important here that you do realize is that the question is, how does temperature affect solubility? And that's where we're going to pull that information from what we observed. All right, now we're going to go to step 3, which is our hypothesis, our educated guess.
Excellent. So at this point, we have made our observation of when water is hotter, more sugar seems to dissolve in it. Our question for today is going to be how it is changing the solvent temperature, meaning what is doing the dissolving. How does that affect the solubility of a solid solute? So a solid one, not a gaseous one, because we did learn yesterday that gaseous ones like CO2 bubbles and soda act differently. So today we're only taking a look at solid solutes like sugar, for example. So we need to make a hypothesis, which again we should be very familiar with already, which is an educated guess or possible answer to the question that is written as an if-then statement. So we've asked a question, now we're going to come up with a possible answer. So if we increase the temperature of water so that it's hotter, what do you think is going to happen to the solubility, the number, right, the amount of grams that we can dissolve of the solid solute in total? What is going to happen to the solubility of that solid solute? Yeah, it's going to increase. Then the solubility of a solid will increase, right? And you want to think about, so more can dissolve, right? Like our sugar in the hot water. On the other hand, we can also say it the opposite way. If we were to decrease the temp of water so that it's colder water, like iced tea, for example, then what happens to solubility? Remember, solubility is an actual number. So what's happening to the actual number of grams that we can dissolve? Yeah, it'll do the opposite. It will then decrease. So solubility of a solid will decrease and less will dissolve. Right? So remember, those are actually saying the same thing, but when we talk about our conclusions, we want to make sure that we are including both ways in which to say this so that we really have a comprehensive understanding of our hypothesis. Go ahead and give me a rainbow if you feel confident about this hypothesis, if this hypothesis makes sense. Hopefully, this is what our experiment supports today. Cool. All right, so I'm going to go ahead and really quickly define independent and dependent variable in case you forgot the definitions. Please note these definitions are not the answer to lab number 3. Please don't write the definition to independent dependent. For number 3, you will get a 0. All right, so an independent variable, what it is what we change on purpose at the start of an experiment. In other words, it's the cause of our experiment. So, for example, adding a certain type of fertilizer. That's something the scientist isn't in control of. It's what they change. It's going to cause the differences that we see later. Dependent variable is dependent on what happened to the independent variable, just like you are dependent upon your legal guardians or parents, for example. According to the state, you're a dependent. All right, so this is the data that we measure at the end of an experiment, in other words, the effect. So for example, you could look at plant growth, the number of leaves, the number of fruits. This is not something that the scientists can control. It's the result of what they originally changed. Go ahead and give me a thumbs up if you feel confident about independent versus dependent. Again, independent, always think about if I'm an independent adult, I can do what I want. If I'm dependent, then what someone else does affects me. Okay? Let's go ahead and take a look at an example here and see how we can apply this. So our hypothesis again is if the temperature of water increases, then solubility of a solid solute will increase, or the opposite, decreases, then solubility will decrease. Now remember, when we look for the independent variable, the best way to find this is just to look at the start of your hypotheses, which I have underlined here. So tell me, what is the independent variable? What are we intentionally changing? So intentionally changing on purpose in our experiment. Is that the solubility of a solid solute, the solubility of a gaseous solute, the temperature of water, or the volume of water? What are we changing on purpose? And what is the cause of our experiment? What are we starting with? Excellent. I have 8 answers, 9 answers so far. Use your polling tools. Getting lots of answers there. Yes, Anissa. All right, looking good. Let me go ahead and publish our results up on the board. I'm going to clear out what I see there. And you are correct. It looks like we unanimously said letter C, and that is true. So the temperature of the water, you can see we are going to say if it increases, so the scientist has to see what happens when it increases, so that's what they'll change on purpose, or if it decreases, which means the scientist has to control that it decreases. All right, so that is going to be our independent variable, and that is actually also the answer to your lab question number 3, part 1. So you can literally type exactly these words, keep the sentence starter, and just after the ... literally type the words, the temperature of water. Again, we are giving you the answer for the first few questions here, as well as all the steps for the later questions. You have 30 seconds. Give me a green check when you have either taken a picture of the answer for part 1, number 3, part 1, or you've typed in your answer and it's been saved. So again, Cody, right after the ... you can put your cursor there and then literally copy what you see here. So the temperature of water. You could also say water temperature. Those are saying the same thing. All right, waiting on green checks, please, from Angela, April, Brittany, Kiko. Waiting on Cody, CJ, Daniel, Diego, Dominic, Hunter, Isaiah, Jade. Again, make sure you're focused. Make sure you're working with us because we are giving you answers. Waiting on Joel, Marissa. Thank you, Marissa. Waiting on Zion, Joel. Waiting on Isaiah, Hunter, CJ, and Kiko, and Daniel. Brittany, green checks. All right, here we go. Moving on. All right, so we figured out the independent variable, the cause. Now we need to go back and figure out the dependent variable. Remember, this is the effect. The effect, what we measure at the end, right? It's dependent on what we originally did. All right, so the easiest way to figure out the dependent variable is now to look at the then part of our hypothesis, the end of it. So then the solubility of a solid solute will increase, then the solubility of a solid solute will decrease. I am giving you your polling tools. Please go ahead and figure out what is the dependent variable in this experiment. Go ahead, take a look again at the underlined parts, the end of our hypothesis, and that should give you a really good hint as to what the dependent variable is. Again, A is the solubility of a solid solute, B, the solubility of a gaseous solute, C, the temperature of water, or D, the volume of water. Looking good. All right, I have lots of people up there. Let me go ahead and publish our responses, clearing out your old ones. Yes, so taking a look here, the correct answer is definitely going to be letter A. So you can see here it says the solubility of a solid solute in both of these hypotheses after the then. It just depends on whether or not it's increasing or decreasing. That's the final effect that we're measuring. So this is the correct answer for the dependent variable. Taking a look at our experiment, the solubility of a gaseous solute is not even applicable because we won't be looking at gaseous solutes. And the volume of water will be what we call a constant or a control because we're going to keep the volume of water the same for each part of our experiment to make sure that the volume of water doesn't mess up our results. All right, so this is the answer for our dependent variable. This goes into part 2 of number 3. Go ahead, give me green checks. Again, just click after the ... and type in the phrase here, the solubility of a solid solute. Green checks when you have taken a picture or save that. I'll give you a couple more seconds because it's kind of a longer phrase. Green checks, go, go, go. 30 seconds. All right, green checks, please. Angelo, Brittany, Kiko. Angelo, Brittany, Kiko, please make sure you're giving us green checks. Thank you, Angelo. Brittany, Kiko, are you there? Hello. Here we go. All right, so let's go ahead and take a look at our actual lab today. So I am going to remind you that you do need to be able to use Adobe Flash. And if you were here at the start of class, I already taught you how to open your lab. So your lab may be blocked by your browser because of Adobe Flash. It's not a problem. I have very detailed instructions on how to get Adobe Flash to work. Those instructions are in the chat box. There's one version if you're in my class, one version if you are in Mrs. Sepulveda's course, okay? So this is extremely important. You do need to be able to open Adobe Flash. Again, give me a green check if you were able to open this at the start of class. I'll give you a couple seconds right now to also try to open it. Okay, this will be a virtual lab and you will be required to gather your own unique data. So in the instructional video for today, I do take you through how to do all the data for NH4Cl, ammonium chloride. Okay, but this is my data and you are not allowed to copy my data. If you copy my data, you automatically get a 0 on questions 4 through 6. Okay, so you can choose any of these other 4. So barium hydroxide, copper sulfate, potassium chloride, or what is this one? Sodium nitrate. You can pick any of those other 3 in order to do your own unique data. Please give me a smiley face if that makes sense. Smiley face if that makes sense. Again, I give you an entire set of data as an example, but do not copy my data. Okay, again, I sent the instructions for how to get Adobe Flash to work. If it does not work, please make sure you stay after class. We can always fix it. We can always fix it. There are no excuses for not being able to do this lab report. No, I'm not coming to your house. All right, so I will go ahead. Mrs. Sepulveda will send out again the instructions as well as the link to the virtual lab. Give me green checks once you have gotten that open, just so I know that you are able to open it up. Give me a red X if you are still unable to open it. All right, so here are those instructions one more time. When you first open it up, you'll see a puzzle piece with a red X in the top corner. I do recommend doing it in Google Chrome because Google Chrome tends to allow Flash to work better. Some of the versions of Firefox don't allow Adobe Flash at all. Okay? Yes. And Laura, I got you. I know that you will be staying after class to help get it figured out. All right. So yes. So click on that puzzle piece. Click Manage. All right. Once you click Manage, that opens a new page. And you'll see a little button on the right side. So click that button so that it turns blue. And instead of saying block sites from running Flash, it will just say ask first. Okay. Once you do that, you can go back to your virtual lab, refresh the page, and then where it says click to enable Adobe Flash Player, click there, and then you should be able to say run Adobe Flash, run Flash, and your lab should work. All right, waiting on green checks from Zion, Juniper, Joel, Kika, Jamie, Jackson, Jade, Chilo, Isaiah. Oh my gosh, Chilo, you are too quick. All right, Hunter, Asia, Dominic, Diego, Daniel, CJ, Cody, Kiko, and Brittany. Again, if it's not opening for you and you're having some different type of error and these instructions aren't working, please give me a red X. And we will make sure that after class we go over it with you. We'll have you share your screen with us and we will get it open for you. There are no excuses. No excuses. I know, Jackson. It can take a few moments to load. No worries. Looking good. All right. I do see the majority of us have figured it out. So I'm going to go ahead and just share it with you up on the board real fast so you get to familiarize yourself with it. So let me pop this up on the board for you and go over what you can see in our experiment. All right. So taking a look here. Computer's being crazy. All right, so what you can see here is, again, you can see 5 different chemicals. You are not allowed to use the first one. So make sure when you do yours, you choose any of the other 4. Any of the other 4 are fine. But for mine, I will be using ammonium chloride, NH4Cl. Now, you can change the temperatures at the bottom. There's 0 degrees, 20 degrees, 60 degrees, and 100 degrees. Okay, so you will need to test each temperature. Remember, 0 degrees is water that's almost freezing. 100 degrees is water that's almost boiling. Okay, and then what you can do is you can add teaspoons of this by grams, 1 gram, 10 grams, or 25 grams. Now, you can do it one by one to get the exact amount. All right, so you could add 1 and add 1. But it takes a long time. So what I recommend, and I'll give you these instructions to you a little bit later, is there's this really helpful undo button. Okay, so you can actually start with the biggest spoon, the 25 grams, and if you accidentally add too much, you can just click undo. Yes, Rosie, so you have to stick with one of these 4 on the right. So you can do any of the 4 and only do those, whichever one you choose, only do that one. Otherwise, you're changing too many variables. Does that make sense, Rosie? So whichever chemical you choose, stick with that chemical for all 4 temperatures. Okay, so for example, you can start with a big spoon like the 25 grams. You'll notice it all dissolves, so I still haven't added too much yet, so I'm going to add another big spoon. And now you can see that it is saturated. There's extra solute at the bottom, so I added way too much. So I'm going to click undo and try my medium spoon. So I can add some from the medium spoon. Oops, still added too much, so I'm going to click undo and add some from the small spoon. Add some from the small spoon. I will show you the spreadsheet in just a moment. Okay, so you've seen that I've added from the small spoon and now I am oversaturated. All right, so I'm just going to click undo one time because I was finally on the smallest spoon. So I just need to click undo one time. And exactly 30 grams is the max amount that can fit into our solution here, into our 100 milliliters of water. Smiley faces if that makes sense. No worries, Yuhan. Yeah, so again, if that's too confusing, you can go one by one. I'm totally fine with that. It's just you should know that that'll take longer. But to make your life easier, you can also start with the biggest one until it's oversaturated, then click undo. Go to the medium one until it's oversaturated, click undo. Go to the small one until it's oversaturated, click undo once, and that will be your final answer. Big, medium, small. All right? Cool, so I'll go over those instructions one last time a little bit later, but I just want to make sure that we understand where we're going to be putting in our data. So you will notice that the links are already in question number 4. Go ahead and give me a rainbow if you see those links in question number 4 already. Excellent. All right, so there is a template in question number 4. Again, rainbow if you see that template. And when you open it up, you will be able to click make a copy and you will see this data pop up. So it's already formatted for you. It's super easy to do. So all you're going to do is you're going to choose your compound. Do not use NH4Cl. You can use any of the other 4. Make sure that you write your compound. You will lose points if I have to try to figure out which compound you used. Okay, so make sure you write your compound in the blue box. And then in the green box, you're going to test out how much you can dissolve at 0 degrees, 20 degrees, 60 degrees, and 100 degrees. And there are actual correct answers, so we will be grading you based on how close you get to the correct answers. Yes, only pick one of the 4 compounds. Yep, only pick one of the 4. All right, as long as, and don't pick NH4Cl. That's the 5th one, so don't choose that one, okay? Don't faint. All right, so that's where you will be filling this in. There are some reminders here. Remember, only type numbers. Don't type any units or letters in here because it will mess up your graph. Make sure you click out of your last box or press enter out of your last box. Otherwise, you will lose points on that because it won't show up when we go to grade it. So make sure you click out of that last box. And then remember, if you don't give us the shareable link, which the instructions are in there, if you don't give us the shareable link, you automatically get a 0 on 4 through 6 until we get your shareable link. So make sure it's the shareable one. Remember that in order to open up the Google template, you do need to have a Google account. Instructions are here. They're also in the instructional video, so I'm not going to go over them right now, but you should be able to have a Google account. The instructional video will take you through questions 4 through 6. After every step, pause, do it in your own lab, and then continue. Please note this is an old video. So in the old video, this was questions 2 through 4, but just know for our current lab, this is questions 4 through 6. Okay, you'll be able to figure it out. Give me a lightning bolt if you understand. Again, I know it's an old video. The questions are a little bit off, but it's still the correct instructions. Still the correct steps. Cool. Question 4, make sure you're logged into Google. Click the template link. Click make a copy. Make sure that you put your name where it says type your name here. Otherwise, it's hard for us to grade a bunch of them at once because we don't know who's who. Make sure you type your data into the table with only numbers. Again, don't put any units or any letters because it will not create your graph correctly. Double check that your graph is correct. Okay, so double check that your graph makes sense and that the data lines up correctly. Okay, you should make sure that your trend line and everything lines up. This is actually really important. I do teach you how to do the trend line in the these steps for number 4, so that's a little bit new. So make sure that you do your trend line correctly. You do have to pick the correct one. So your trend line does have to be the correct one to get full points on this. Okay? Yeah, I don't understand why people don't put their names on stuff either. And then make sure that you copy and paste your shareable link into question number 4. Do not use the URL from the top. That's an automatic 0 on 4 through 6. You have to give me the shareable link. And the instructions are in the video, the instructions are in the template, and the instructions are in the lab report. They're everywhere. Okay? And again, if for some reason you want to add 1 gram of solute at a time, you can. It just takes a long time. Remember, this is the faster method. Add the big spoon. If there's no undissolved compound, keep on adding more. If there's too much, click undo. Then start with your medium spoon. If it all dissolves, add more. If it doesn't all dissolve, click undo. And then go to your small spoon until there's no more undissolved compound. Click undo once, and that last number will be your answer. And that's how you will do number 4 for 0 degrees, 20 degrees, 60 degrees, and 100 degrees of water. Okay, so yeah, big, medium, small if you want to do it faster. So at this point, everyone, we have answered question number 1 together, right? So we talked about, sorry, let me blow this up. We talked about our independent and dependent variable. Make sure those are filled out here already. Now we're going to go ahead and work on question number 2. And so you need to open up both of these links. So there's the virtual lab as well as where you are going to actually be typing in your data. Okay, so I'm going to click both of these. All right, again, if it says run Adobe Flash, you can click run Adobe Flash and allow it. And that will allow this to open up. And then you also, again, need to open up your second link, which is where you're going to actually be putting your data. All right, so we're going to open that up, click make a copy. Please, 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 if you can, remember to type your name at the top, right? So where it says type your name here, please make sure you actually click in there and type your actual name. Otherwise, it gets very confusing for me as I am grading those. Okay. All right, how are we doing so far? Give me smiley faces if you feel good about everything I just talked about. Confusion faces if you're having any issues so far. Looking good. All right. Got some smiley faces. Love it. Looking good. All right. So those are the 2 links that I should have open. So here we go. What we can see here is we can see 5 different chemicals. All right. Sorry. Let me blow these up a little bit. So we can see 5 different chemicals right here. Okay. So NH4Cl, BaOH2, so barium hydroxide, copper sulfate, CuSO4, potassium chloride, KCl, or sodium nitrate, NaNO3. Okay, so these are the 4 different compounds that you can have. Now, again, you are not allowed to use the first one. Okay, so I tell you here in the blue box here, do not use NH4Cl. Okay, that is the one that I am using. And so you cannot use that one because then you'll have the same data as me, which is cheating. Okay, so what you'll do is you're going to choose one of these 4. So choose any of these 4, and then you're going to type in which of those that you choose. Okay, so again, my example, I'm going to use NH4Cl. So I would type in NH4Cl. But again, you guys should not do that. You should definitely choose a different type. All right, so again, I'm going to type here, don't use this one. All right, smiley faces, everyone, if that makes sense. All right, so my example is NH4Cl, but everyone else, do not use that one. Use any of the other 4. Perfect. Okay, so what you are going to do is you're going to set your temperature at 0 degrees. Okay, so I'm going to set this at 0 degrees. which it's already set to. And I'm going to begin adding compound to see how much will dissolve. Now, if you want to, you can add it 1 gram at a time until it stops dissolving. However, I find that that takes a very long time. So I don't like to do 1 gram at a time. So I'm telling you right now, if anything else is too confusing for you, definitely just add 1 gram at a time, but there is a faster way to do it. So the faster way to do it is to use the bigger amounts first. And if you add too much of the bigger amounts, you then click undo and try a smaller amount. Okay, so I have the directions right here of how to do that, and it'll also be in the recording, and you can take a picture of it later when we go back to the whiteboard. Okay, but first start by adding the bigger amount. So add 25 grams. Okay, you'll notice it all dissolved, so we're good. So I'm going to add another one. Okay, so at this point, there's some that has not dissolved. So that means that adding this extra spoonful was a mistake. Smiley faces, everyone, if that makes sense. So now there's leftover that didn't dissolve. So this extra spoonful was a mistake. So what I'm going to do is I'm just going to click undo, and I'm going to go down to the next smallest amount, which the next smallest amount is the 10 grams. All right, so I'm going to add 10 grams. Okay, again, that 10 grams is too much. So what should I click? That 10 grams was too much, so what should I click? Yes, I'm going to go ahead and click undo. All right, and now I'm just going to go to the next smallest spoonful, which is the single gram. So 1 gram, add another one until it stops dissolving. Okay, so at this point, I've added, again, too much, so I'm going to click undo. However, there isn't a smaller spoonful for me to use, so this is going to be my final answer. So after I click undo for the last time, this one right here is my final answer. So this says 30 grams, so 30 grams right here would be my final answer for 0 degrees. Smiley faces, everyone, if that makes sense. Again, if you need to, you can add 1 gram at a time. I'm just telling you, it's going to take you a long time to click 1 gram 30 times. Okay, this one was for 0 degrees, which is the cold one. Okay, again, don't copy this data because this is for the first chemical, which is one that you're not allowed to use. Okay, excellent, everyone. Okay, so now I'm going to go ahead, I'm going to reset this and set it to 20 degrees Celsius. All right, so I'm going to set it to 20 degrees Celsius now. Yeah, so you click on the red button to make it 0, the green button to make it 20, the blue button to make it 60, and the yellow button to make it 100. Okay, so now we're at 20 degrees. Okay, so I'm going to do the same exact process. Where did my picture go? Again, start with the biggest spoonful. Dolly, you should just be watching for now. All right, so eventually you'll do all of these with one of the other compounds, but don't do the exact same steps as me because you should be using a different compound. If you're using the same compound as me, that is plagiarism, okay? All right, so now I'm going to go ahead. I'm at 20 degrees, and I'm going to start again. So again, if you want to go faster, start with the biggest spoonful. Once you have too much, click undo, go to the smaller one. Once you have too much, click undo, go to the smallest one. Okay, one last time. Give me a green check, everybody, if that makes sense. This process of how to make it go by faster. If that's too confusing, just add it 1 gram at a time. Just be aware it's going to take you a lot longer. Excellent. All right, so I'm going to add the biggest spoonful, 25. Going to add another one. Oh, that was too much. So I'm going to go ahead now and click undo and go to the 10 gram, the smaller one. So add 10 grams, add another 10 grams. That's too much. I'm going to click undo. And now I'm just going to add the smallest one, 1 gram at a time. Okay, so at this point, now I've added too much, so I'm going to click undo one last time. And since there is no spoon that's smaller than this is my final answer. So my final answer will be 38. You should do 10 grams and then 1 gram, Efren. So you go from biggest to smallest. So start out with 25s. Once you have too much, click undo, then go to 10s. Once you have too much, click undo, then go to 1s. Once you have too much, click undo, and that's your final answer. Okay? All right, so then you can do 60, right? So we can change this over to 60 degrees now. Add our 25. Add another 25. Let's see, just keep on going until it stops. All right, that was too much. I'm going to click undo. Try adding 10 at a time. I didn't. I tried 10 first. You might just not be able to see it. It might be a little bit too small for you to see, but I actually did 25, then 10. Yeah, exactly. So you should do 25, then 10, then 1. You're correct, Efren. I think maybe you just missed it. But that is what I did. Okay, so I just added 10 and that was still too much. So I'm going to click undo and try adding 1 at a time now. You can't click both of them at the same time, Efren. So you can only click 1 at a time. Okay, once you start doing it, it'll make a little bit more sense. Okay, and again, these instructions right here are what you're going to want to have. Yeah, whatever you need to do, Efren, to get there, that's what you need to do. All right, so at this point, I've added too much. I'm going to click undo, and there is no smaller spoon, so I'm going to type in 56 here. And then last but not least is my 100-degree one. Sorry, guys, I'm trying to do this quickly, so give me a moment to do that. Okay, at this point, I've added too much, so now I'm going down to 10 grams. Still too much, so click undo and go down to 1 gram until it stops dissolving. And again, this will be in the recording, so definitely if you get confused at any point, you can just come back to the recording. At this point, there's too much, so click undo, and since there's no smaller spoon, that's my final amount, 78. All right, so go ahead, everyone, give me a thumbs up now if that makes more sense. All right. Again, those instructions should hopefully be helping you out. Cool. Perfect. All right, so that's our data, right? So for the NH4Cl, which you should not use, so for the example data, this is what I got, 30, 38, 56, and 78. Now, you'll notice that I did not put any letters next to these numbers. You should never put letters because you'll mess up the graph. So don't put grams. The word grams is already included in the title. So you just put the numbers. Again, you should be getting unique data because you're not using NH4Cl. So you should get totally different data. You can use any bottle except for the first one. Exactly, Dree. So you can use the second, third, or fourth bottle, or sorry, second, third, fourth, or fifth bottle. Just do not use the first one. And then make sure that you click enter. So a lot of you are losing points, just so you know, on this last box because you type something in and then you don't press enter and it doesn't save it. So make sure you always press enter so that you actually save that last box. Smiley faces if that makes sense. I have that reminder here, but always click enter out of your last box so that you get credit for it. Okay. Now what you're going to see here, everyone, is you are going to see that your graph has automatically populated for you. Okay, so it's automatically updating for you. And this is what you can see here. Now, the thing is, some of these, for all of the other compounds that you use, this straight line is not going to work very well for predicting what you're going to be doing for your question number 4. So basically, the trend lines for all the other compounds, for the most part, do not line up with the dots correctly. So this is the last thing that we need to talk about, and this one is going to be different than what we've done in the past. So what you'll need to do is you'll need to go ahead and double click on the trend line. Okay. All right, double click on the trend line. So this green line right here. Okay. And down here, scroll down to where it says trend line and it says type. Okay. So currently the type that I have is linear. And what your goal is to try to get this to match up as well. And you'll know that it matches up as well as it possibly can when this R squared is as close to 0.99 or even 1.0 as possible. Okay, smiley faces, everyone, if that makes sense. So we're trying to get this as close to 0.999 or as close to 1.000 as possible, this R squared value. Okay, so linear, you can change it to exponential. And you'll see it stayed the same, so exponential doesn't help me. You can change it to polynomial, and look, you'll see that at polynomial, it turned into a 1. So polynomial is the best fit, okay? So do not try moving average, but you should try linear, exponential, polynomial, logarithmic, and power series until you get this to either equal 1 or as close to 0.999 as possible. So again, you want it to equal 1.000, sorry, let me put this here. Equal to 1.000 or close to 0.999 as possible. Okay, everybody, go ahead and give me a smiley face one last time if that makes sense. So this R squared value, you want to make sure your trend line matches up with that. Otherwise, what you will find is that for some of the compounds, the trend line does not match up with the dots at all, and it's going to give you a incorrect answer for your last question. Okay? Efren, did that answer your question? Okay, perfect. All right, so that's all you need to do for that. Now at this point, you're going to click share, click Get Shareable Link, click Copy Link, and then go back to your lab, and that's where you put your shareable link. And that will answer question number 2, and question number 2 will be all set. So you can either right-click and click Paste, or if you have a PC, you can press Control and V at the same time. If you have a Mac, you can press Command and V at the same time to paste your link in here. Again, make sure you follow these instructions from the share button. Do not give me the copy link at the top because that is your personal link and you will automatically get a 0 because I won't be able to see your graph. Even if you spend a bunch of time making sure it's perfect, you'll get a 0 because I cannot see it. So make sure you follow the directions correctly. Okay. Yes, Damien, this is all being recorded right now, so that will be in the recording. All right, so question number 3 asks you to make your conclusion. Okay, so you're going to say our hypothesis was if temperature of water increases, then solubility of the solute will increase. Now, taking a look at my data, guys, again, your data may not be the same, so don't copy this. Okay, but I am going to show you an example of how I would answer this. So I would say that mine is supported, okay, by my data because my solid solute, which for me was NH4Cl, which is my example, okay, at a high temperature like let's say 60 degrees. So for mine, let's say I say 60 degrees for my example. It dissolved a maximum of, right, take a look at the number next to it, 56 grams, right? So 56 grams is my example. Which is less or more? So tell me in the chat box, is 56 a smaller or a bigger number than these colder temperatures? Is 56 going to be more or less solute than what we got at these lower temperatures? Yeah, 56 is a bigger number. So this is more solute than dissolved at these lower temperatures. So again, this is my example. So more than the amount that dissolved at the low temperatures. Because, for example, at the low temperature, like 0 or 20, so for example, let's say I say 0, okay, so 0 degrees, the maximum that dissolved was only 30 grams. So 30 grams was my example. And so this proves that as temperature increased, as I got to higher temperatures like 60 or 100 degrees, the amount of the solubility of the solid solute, the amount that dissolved, definitely increased. Smiley faces, everyone, if that makes sense. It definitely increased, right? We see bigger dissolving numbers here than down here. Bigger numbers here than down here. Excellent. Thank you, Noah. Looking good, looking good. All right, cool. So the last thing that you guys need to do, so again, this will be in the recording, or you can always take a picture of it from the recording if you need to. The last thing here is question number 4 asks you to use your trend line. Please make sure you use your trend line. Do not just try to make a prediction. All right, so I will be grading you based on how close you are to the correct answer, and there is a correct answer. So please, please, please use your actual trend line, okay? So using your trend line, you're going to try to predict how much of the solid solute that you chose could dissolve at 40 degrees. So what you're going to do is you're going to take a look at 40 degrees. Let me take a picture of this. All right. So you're going to take a look at 40 degrees, which is right here. Okay. You're going to go ahead and draw up until you get to your trend line, the green line. And from there, go straight to the left until you get to the solute line, okay? So if you take a look at this, everyone, each of these lines is 10 grams. So 10 grams, 20 grams, 30 grams, 40 grams, 50 grams. So since this is between 40 and 50 grams, a little bit closer to 50, I would say that this would be about 46 grams that I predict would dissolve. Smiley faces, everyone, if that makes sense. Okay, so again, start at 40, go up to the line, go to the left. Again, each of these dashes is worth 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, so on and so forth. Excellent. Looking good. And that's all you need to do, and you will be done with the lab.
We're obviously designing an experiment using that hypothesis, that scientific method, graphing and analyzing that data. We're going to look at how we demonstrate changes in the temperature, how it affects the solubility of that solid solute in water. It's our question. And so obviously we did this by our lab report. Hopefully we'll be getting an 80% on that. So with that being said, go ahead and tell me, how do you feel about doing this lab? Are we feeling okay? Are we feeling a little kind of, a little shaky. Tell us, I'll give you your whiteboard tools. With your whiteboard tools, show me where you are at right now with this lab. All right, good. Okay, and that's okay if we still need some help because we're here for you. We're going to stick around for a moment just to kind of see, you know, if you need any help. Absolutely. Good. I'm glad we're still, nobody is really right here, very confused, but, you know, still need help. That's okay. That's what we're here for. So we're going to go ahead and help you with that. Thank you for your input, everybody. All right, so let's go ahead and look at this. So today we want you to complete your 6C lab report. It is due at 4 p.m., but I think it's more important that you actually get it done right. So we are not going to start correcting or anything like that. We're probably going to give you, I would say maybe a couple of days. We may start correcting tomorrow, but maybe the next day, you know, just to make sure that you get it in right and completed correctly. We don't want you rushing in this. We don't want you to, that's our biggest pet peeve when it's half of it's done because you just kind of rushed through it to get it done. So please don't do that. Get it done correctly. It's okay if you're late, but we just give you a time frame just to kind of give you some guidelines. That's about it, okay? So get it done, get it in, and get it correct. With that being said, we're going to go ahead and stop the recording.
Recording stopped.
And then if you miss that normal attendance check, we do have that alternative attendance check and you need to get that done in by Thursday by 4 p.m. That is tomorrow. So with that being